Okay, this is section 1-2, and its topic is on relations and functions. Your journal choice for this section is compare and contrast the terms function and relation. Keep in mind you have to choose one journal and you have 3 choices. You can do the one from section 1-1 or the one from the next section 1-3. Okay, here we go. Objective and what's the point? We are going to learn some important words today. I can't tell you enough how important these words are. Function, independent variable, and dependent variable. This is learning target 6. And the reason we do this is that functions and the variables that go along with functions are fundamental to advanced mathematics. It's kind of a cop-out answer today, to be honest. Although everything you learn from here on out is going to be based on functions. Basically, math is the study of relationships between numbers, and the ones we know the most about are functions, okay? And so that's basically what we study. All right, let's go on. Words to know, and there are a ton of them, and it is imperative that you understand these words at the end of this section. Make sure you ask tomorrow if there are any of these you are still wishy-washy about, because this is super duper important, okay? You will understand better as the lesson goes on. A relation, basically any set of ordered pairs that anybody could ever come up with is a relation. If you have ordered pairs, x comma y, x comma x, anything, they are going to be a relation. We can express them as a table, a graph, because you can graph anything that you put in a table, the t-table, you guys did that in algebra, or you could list them as ordered pairs, okay? Now, a function, and this is the big one today, is a special relation. It is only a certain kind of relation. And most of the things you can think of are functions, so it's going to be hard for you to think about what's not. But in this case, each x only has one y, okay? And we will give more examples to this later. But basically, it's a relationship where if I say, how far can you run in 3 hours? You're only going to give me one answer for how far you're going to run. You can't say, I can run 4 miles. It's really slow. Or maybe 15. No, I need a set answer. You have to give me one answer. You can't give me 2 answers, because otherwise I wouldn't know what to write beside that, okay? Independent variable is the value we can pick. It is the input, okay? It's the x value in the ordered pair. Usually, whenever you guys are graphing lines, you remember that in Algebra 1? You picked something for x, you plugged it in, and you got y. It's what you can pick. It's independent. You know the Kelly Clarkson song, Miss Independent, because she wants to stand on her own. It's one you can pick, okay? Dependent variable, on the other hand, is the one that is the output. After you pick something, you plug it in, what do you get, okay? The dependent variable depends on what you picked for x. It is the y value in the ordered pair, okay? Input, independent value, x, dependent, y value, output, y. Okay? You will have a couple issues with this probably your first few days with this. It'll get better though, okay? Now, is a function of, this is going to show up on quizzes, tests, your homework. When we talk about the special relationship functions have, we need to say which one depends on the other, because it will make a difference, and you will see that in a minute. So when you see the words is a function of, it means the exact same thing as depends on. To check which one is dependent and which one is independent, you might change it to depends on. If I say y is a function of x, that means y depends on x. In this case, y depends on something, so that's your dependent. X is your independent. X is the one you can pick. Okay? Domain and range. This you will deal with all the time from here on out. It's incredibly important in math because it's talking about graphing, what's allowed, what's not allowed. It will forever be used in trig and calculus. You really, really, really want to understand this today. I cannot stress enough how important it is. You ask questions if you're still having issues with some of this vocab at the end of the lesson. Domain and range. Domain tells you what you can pick for X. Okay? What can I plug in for that first column on the table? Range is what could be the outcome. What can come out of Y? Okay? Go back to the how far can you run thing. Okay? If I say X and Y. X in that case was time. Y in that case was miles. Domain is what you can pick for X. What can I pick for time? You guys are like, you can pick whatever you want for time. I could say, how far can you go in an hour and a half? How far can you go in 20 minutes? But can I pick anything? Can I say -5 hours? Of course not. You can't have -5 hours. So there are restrictions to the domain, we say. You can only pick positive numbers in this case. The domain is positive numbers. Okay? Same sort of thing with range here. What might come out of Y? Well, there's a lot of things. I might not go anywhere. I might stand still. I might go super slow. But you can't have negative distance. Some people say you might go backwards. But I'm saying if you're running in one direction. So don't be a smart aleck. Again, you have to have positive numbers. A lot of times, positive numbers are your domain and range. Okay? Now, the big thing is that a lot of students have a hard time with here is that they get confused. Which one is for X, which one is for Y? Because it's one of those things some teachers say you just have to memorize. Domain goes with X, range goes with Y. I have an easy way that might help you remember. This is how I remember. If your math teacher, Mrs. Bruno, randomly came into class one day and started singing horribly off-key, a song that you might know that has the word range in it. Does anybody know a song with range? About this one. Home, home on the range. Okay? What would you probably say to your neighbor if I came in to sing that? You would say, why is she singing? Why am I cursed in her class? Why, oh, why, oh, why? Range, why? Okay, so hopefully you can remember that way. Range goes with Y, because if Mrs. Bruno sang that horrible song, you would all say Y. Okay, the last word you need to know is mathematical model. It's a real situation that can be described using math, lots of them in geometry. There's lots in everywhere. This is not the most important word. The big ones today, relation, function, independent, dependent, domain, and range. This is a function of, it's important, but it's more just to help you work on problems and figure out the relationship. Lots of big words today, okay? All right, so the one you're probably most confused of still is the function. How can you tell if the relation, because everything is a relation if you remember, how can you tell if it's a function or not? Okay, we're going to do some practice here in 1 second. There are 3 ways you can tell. Like I said, for each input, there can only be one output. So for each value in the X column, there can only be one value in the Y. So one way you can do is you could look at a table. No value on the left side can repeat. It's not allowed to repeat. If it did repeat, it has to be like a copy-paste. It has to be exact clone of the one before it. In other words, you can check the independent variable, which is usually X's, and if they repeat, it's probably not going to be a function unless it's the same one. Okay? That's one way. The next one is the one you guys will remember all year, and anytime I'll say, how can you tell if it's a function, you're all going to say vertical line test. It is the easiest way to check, but it is also not very convenient, because if you are given a table, you would have to graph the table first, and we don't always want to graph something if we don't have to. But if you have a graph, it's very easy to tell if it's a function or not, because a vertical line will only touch it one time, for the same reason as I was just saying with the table. Okay? The last part is check the ordered pairs, and this is the same as checking the table. You check the X's, you look for repeat, and if anything repeats, you need to make sure it's an exact same match. So let's look at an example here. Here's an XY table. 2, 3, 4, 5, 6, 7, 8. Is this a function or not? Okay, and the way we can tell if it's a function on a table is you check the x's. The only thing you have to do is say, do any of my x's repeat? 1, 2, 3, 4. Do any of them repeat? The answer is no. So is it a function? Yes. It is a function if there are no repeats. Okay, here's another one. XY. 1, 2, 3, 4. 1, 1, 1, 1. Is this a function? Yes or no? When you have a table, the only thing you have to do is check the x's. Do they repeat? No. So is it a function? Yes. Okay? Now, what about these ones? Some of you might say, oh, there's a repeat. Only check the x's. That's the only thing that matters with functions. Okay? It doesn't matter if I'm asking how far you run in 1 mile. I get 1 hour, just 1 mile. 2 hours, 1 mile. 3 hours, 1 mile. 4 hours, 1 mile. Doesn't matter. Okay? It's still a function because you only have one answer that you're getting. Okay? How about this one? Is this a function? What do? You check the x's. Are there repeats? In this case, yes, there are repeats, okay? This is a problem. I don't know what's going on here. Sorry. All right, this is a problem, as is this. Now, there is a catch. Yes, there are repeats, but I still am getting the same thing here. 2 goes with 1 both times. 1 goes with 1 both times. So this is still a function because even though there are repeats, if I plug in 1, I'm still just getting 1. If I plug in 2, I'm still just getting 1. So you guys are all asking now, so what's not a function? Well, let's look at this again. 1, 1, 2, 2. 1, 2, 1, 2. This is not a function. I have repeats, so I check them. Oh, this one has a 1, but this one has a 2. They are not clones of each other. They don't match. Same thing here. You are only allowed to get 1 number out. So this is not a function because the x's repeat and they did not match up. So if the x's repeat, you say, do they match? And if the answer is no, then guess what? Not a function. Okay? We can do a couple more examples tomorrow. Look through your homework. You might not need them. We'll see what we got. How about graphs? What is a function when you graph it? Okay. Let's look at a line. Is a line a function? On a graph, you do a vertical line test. No matter where I draw a vertical line, it is only allowed to touch the graph 1 time. Any line I drew only touched it once. So is it a function? The answer is yes. And this should make sense to you because you guys have done so many t-tables with graphs. If I plug in 0 on a line, I'm just going to get 1 number back. I don't get 2 numbers back. There's only 1 possible numbers. If I plug in 1, I'm just going to get 1 thing. It will never shoot out 2 different answers. So if I checked the x's on a line, none would ever repeat. Okay? How about, what other graphs do you guys know? How about a parabola? Is it a function? Okay, well, let's do the vertical line test. Touches once, touches once, touches once, touches once. Dun, dun, dun. It only touches once. Is it a function? Yes. Passes the vertical line test. How about this sideways parabola? Is it a function? Touches 2 times here. This is not a function. Okay, here's a question. Are all lines functions? Okay? Are all lines functions? And I want you to think about that, and I want you to tell me the answer tomorrow. are all lines functions, okay? So, one last time. How do you check if something's a function? If it's a table or ordered pairs, check the x's. Do they repeat? We don't want them to repeat. If nothing repeats, it's a function. If they do repeat, you need to check. Make sure that they have different. If they're different, then it's not a function. How do you check on a graph? Vertical line test. There's one more graph one I wanted to look at before I forget. Okay. How about this one? Is this a function? Touches once, touches once, touches once, doesn't touch at all. Oh, touches 3 times. It's not a function. And this will kind of drive home the whole table thing. If I made an XY table of those points, let's say that was like -4, -2. -2, 2. What happened here at 2? Well, one time it was -1, one time it was 2, one time it was 3. Do you see how they didn't match up? It's not a function. Okay? All right, back to the notes. Practice with functions. Sometimes determining the independent variable from the dependent is tricky. For example, on example 1 in your reading about triangles, they're asking which angle was dependent and which was independent. It really will depend on which one you solve for. It was kind of a stupid question in that case. I'm going to give you a stupid question here in a second. Usually you can tell which one is easier, will be the one you choose, but sometimes there can be more than one answer, and that's going to be okay. So just something to be aware of. Here's an example. 2 angles in an isosceles triangle have the same measure x. You guys know that from geometry. The base angles of isosceles triangles are congruent. The measure of the third angle is going to be y. You guys all know there was a shortcut. You could take 180, because the angles of a triangle add to 180, minus 2x, because those two are the same, will give you what y is. Which of x or y is dependent and which is independent? Explain your answer. If you were going to pick one to plug in, I think most of us would pick to plug in for x here, right? If x was 10, what would y be? If x was 20, what would y be? And so on and so on. So in this case, what is easier to plug in? It's easier to plug in x, so that's what I would like to pick. So x will be independent and y would be dependent. Now technically, because y will depend on what I plug in for x. Technically, yes, somebody could say, well, I wanted to plug in y and then solve the other way. Sure, you could do that, in which case it would be vice versa, but what makes more sense in this case, okay? It makes more sense to plug in things for x. Okay, hint. Time is a lot of time. The independent variable for that example I told you about running, how far can you run it? 3 hours, 4 hours, 5 hours, because that's something we plug in a lot. So that's something to keep in mind. Here's a really good example. The average annual price of crude oil per barrel in the year Y is given by the following table. So let's look at this table. Here are the years. Here's the price per barrel. Is Y a function of P? Again, you're going to be asked this question a lot, so you need to make sure you know what you're doing. This is asking, does Y depend on P? So that would make Y dependent and P independent. Which one do you check to see if it's a function? You check the independence. What am I checking for? Repeats. So in this case, I'm going to go to P and I'm going to check for what? Repeats. Do any of these numbers repeat? Oh, 1675, 1675. Do those match? No. So does year depend on the price? The answer is no. It does not. Because 1675 had 2 different years, and that's what you would say for y. Okay? Now, this one asked, is p a function of y? And this is how I do it every time, guys. Does p depend on y? So in this case, p would be dependent, y would be independent. Which one do you check? You check the y in this case. I'll do this in pink. No repeats, nothing repeats. So does the price depend on the year? Absolutely, it sure does. Nothing repeats. Some of my students last year did on these questions always remember when it says, is y a function of p? So always check the last one. Yes, that will work, but I think it is a little more helpful to write it out like I am. Okay? Now that's all I have for you today. Enjoy your homework. Thanks.